Everybody. All right, so now that we've looked at scatter plots and we've talked about how to describe or examine a scatter plot with direction, form, strength, and a discussion about outliers, now we want to do some actual assigning of some numbers so that we can quantitatively use numbers to describe how strong a scatter plot is. And the reason why you use scatter plots is so that you can make predictions, and predictions is very important in statistics. And one way to do that is by examining what's called the correlation. We use the letter R to talk about correlation, and I have the definition in the middle of the screen here. The correlation R measures the direction and strength of the linear relationship between two quantitative variables. And so correlation is measured. It has no units. It's measured as a quantitative value between -1 and 1. The closer it is to 1 or -1, the more linear the scatter plot's going to appear. The closer it is to 0, the more chaotic. And let me give you an example of a picture. Now, as often as the theme with statistics, there is a formula to come up with to discuss correlation. We don't look at the formula, okay? We just take the fact that we know what correlation is, and it gives us all we need to know in an AP statistics class. Okay, so I have 6 pictures here. Here in the upper left, this is an example of a graph that has a correlation of 0. What you should see is kind of chaos with the dots. Now, if you go to the other extreme, here's a correlation of -0.99. What you should see is this, is that the dots look relatively linear, and the direction is a negative association. That's what you should see there, okay? And then these other scatter plots are somewhere in between. Remember, chaos when it's close to 0, when it's close to 1 or -1, then it's more linear. Here's example 1 that's really close to 1, right? Do you get the positive feel for the association and how the dots are relatively close together? All right, so now let me show you a picture. And here we go. Here's an example of 4 pictures right here, and they describe right underneath the check for understanding what these scatter plots represent. And here's what you could be expected to do. Estimate the correlation, and then interpret the value of R in context. Okay, so take a look at those 4 pictures. I'm going to pause for just a little bit. And then I want to show you answers. Do you see some that have positive correlations, some that have negative correlation, and do you see some that are chaotic? You might even make a guess here in the next 10 seconds before I display what the answers are. Okay, so I think I can click on this, and there we go. So the first one, the question that had a scatter plot with boats and manatees, says that the correlation is about 0.9. Okay, again, relatively linear, close to 1. And here is the interpreting the value of R in context, which you will be asked to do. So this indicates that there's a strong positive linear relationship between the number of boats registered in Florida and the number of manatees killed. Always make the correlation between what you have as the explanatory variable on the x-axis to the response variable on the y. For part B, the storms predicted and storms observed, R is about 0.5. See how these are more spread out than part A was? This indicates there's a moderate positive linear relationship between the number of, and I don't have the rest of the answer there. And I kind of wasn't paying attention to myself talking. Let me get it. So this indicates there's a moderate positive relationship between the number of named storms predicted and the actual number of named storms. Okay. Part C, R is about 0.3, more spread out than the other 2 graphs. This indicates there's a weak positive linear relationship between the healing rate of the 2 front limbs of the newts. Okay, 2 front limbs of the newts. And then part D, R is equal to -0.1, more spread out than the other 3 graphs. This indicates that there is a weak negative linear relationship between last year's percent return and this year's percent return in the stock market. So you can hear me describing direction, form, and strength in those in those descriptions, interpretations of R in context.